Finding the area of a sector. And just a reminder, a sector is a section of a circle, like a piece of cake or a piece of pie. Here's an example, and there was another example on the first page I gave you. So this is a sector. So the formula we're going to use is area equals theta over 360 times pi r squared. Theta is the inside angle, which is 120 degrees. And r is here, 7 meters. Might just label these. Oh, that's a terrible looking R. R and theta. So R is 7 squared. Put all this in the calculator and you end up with 51.31, and we're trying to find area, so it's going to be in these units squared. Area of composite shapes. Next. Composite shape is a shape that doesn't fit one of the formulas above, and it's usually made up of 2 or more smaller shapes that you can break it into and then add the areas together. So what I've suggested here is that you redraw the shape as 2 or more smaller shapes and then add them together. So for this one here, it might take a bit of working to work out what your smaller shapes are. So it'd be a good idea to use a pencil. I've had a look through here and I can see if I cut it like that, I end up with a semicircle on this side and a trapezium on this side. So I still need to write my formulas first, but I'm going to write it a little bit differently. I'm going to say the area, the total area equals the area of the semicircle plus the area of the trapezium. Now, when you get used to this, you might write it like this. Total area equals area of circle plus area of trapezium. You need to have a TR there, so it's not the same as this one. That's okay as well, but you need to have some way of showing how you're working out your full formula. So we then write out the formula for each one of these. So area of a circle, this is actually a semicircle, so it's going to be a sector. Actually, I might rewrite that as a sector. Area of a sector is theta over 360 times pi r squared plus area of a trapezium, which is a half a plus b times h. Next step, if it helps you, you can put these in big brackets so you can see the 2 parts, or you could even draw them in different colours. Might just make this plus look a bit more like a plus. Okay, next step is to substitute our values in. oh, sorry, first of all we need to make sure they're in the units are the same. We've got meters, 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 so that's okay. Now we can substitute. So our theta for this is this internal angle of just the semicircle. So it's going all the way around, it's 180 degrees over 360 times pi times the radius, which is this bit here. I've kind of drawn over it, but there was a dotted line there. So that's the 1.7. Plus a half. Now the A and the B. The A was this one, the shorter length. And B will be this longer length. Now we know this much. This is half of B. So it's just going to be 2 times this amount. 2 times 1.7 is 3.4. And then we need to times it by this height of the trapezium, which is this length here. Next step, calculate. Put it all into the calculator. You don't need the red brackets, they're just there to help organize it for you. And you should end up with 8.70, and we're finding area, so it needs to be square units, and these are all meters, so it will be meters squared. Thanks for listening to the video.